When we imagine Mars, we often see a cold red desert, but look closer and you'll find something familiar, waves of sand sculpted by wind stretching across craters and plains. Dunes on Mars resemble those on Earth, yet they form in ways that are stranger, larger, and at times more mysterious. Today on Cosmic Compass, let's explore the dunes of Mars, how they form, how they move, and what they reveal about a planet that is both familiar and alien at the same time. For more than a decade, NASA's Mars Reconnaissance orbiter has been circling the red planet, capturing extraordinary images with its HiRISE camera. 10 years of daily imaging has given us a massive catalogue of Martian landscapes, allowing us to zoom in and study details of the planet in ways Galileo or Lowell could never have imagined. Among the most fascinating features are dunes, waves of sand sculpted by wind. On Earth, dunes are symbols of deserts, the Sahara's towering crescents, the rolling Namib, or the endless sand seas of Arabia. But what happens on a world with a thinner atmosphere, weaker winds, and no seas or vegetation? Do dunes on Mars behave like ours, or do they tell a different story? Today, let's take a closer look at the dunes of Mars. We'll compare them with their earthly cousins, explore the 5 main dune types, and discover one form that Earth simply doesn't have. Along the way, we'll see how dunes move, grow, and even surprise us, reminding us that Mars, though familiar, remains a world full of mysteries. On Earth, dunes are classified into 5 primary types, each shaped by the wind, the availability of sand, and the obstacles in the environment. These same categories apply to Mars, but with a twist. Our neighbour boasts variations and scales that defy expectations. The most common dunes on Earth are crescent-shaped barchans, found in deserts across the globe. Then there are long sword-like Seif dunes, small dome dunes, parabolic dunes near coasts, and the towering star dunes where winds shift constantly. Mars has all of these, yet with unique features that make its dunes alien and in some cases more massive than anything on Earth. So let's travel dune by dune, starting with the humble but plentiful Barchan. Barchan dunes are the classic desert dunes, shaped like crescents with 2 arms stretching downwind. They form wherever sand supply is steady and wind blows predominantly from one direction. One side is a gentle slope facing into the wind, while the other is a steep slip face where grains tumble down. On Earth, these dunes march slowly across desert plains, their shapes shifting with every storm. On Mars, they gather in craters, often at the base of vast impact basins. From orbit, we see clusters of barchans merging into rippling sand seas or isolated crescents scattered across dark plains. You might expect these Martian dunes to be frozen in place. After all, the atmosphere on Mars is only about 1% as dense as Earth's. How could wind possibly push sand grains in such thin air? For years, scientists thought the dunes might be immobile relics of an earlier climate, but HiRISE images proved otherwise. By comparing photos taken years apart, researchers saw dunes moving slowly but undeniably. Some shifted by several meters over the span of a Martian year. The secret lies in the sand itself. Mars doesn't have the coarse quartz grains we know from beaches. Its sand is finer, lighter, easier for wind to lift. With the right gust, even a thin atmosphere can move mountains of dust. Imagine standing at the edge of a Martian crater, watching as a crescent dune, hundreds of meters long, creeps almost imperceptibly across the plain. In the short span of a human lifetime, you might not notice, but over centuries, the dunes migrate, reshaping the Martian landscape grain by grain. What happens when winds shift direction? Instead of crescents, dunes stretch into long, narrow ridges known as Seif dunes, named from the Arabic word for sword. These ridges can run for hundreds of kilometers on Earth, aligned in striking parallel rows, separated by gravel corridors. On Mars, we find them too. In some craters, dunes run like sharp dark blades across the basin floor, each one etched by alternating winds. From above they appear marked with dusty streaks that highlight their crests, almost like brush strokes across the sand. One fascinating detail is how some Martian barchans appear to be mid-transformation, caught between crescent and Seif. Wind shifting direction slowly sculpts them into long ridges. In a single orbital image, you can trace this process: small crescents at one end, elongated ridges at the other, like watching evolution frozen in sand. These Seif dunes remind us that Mars is not static. Its winds shift, seasons change, and even in the thin air, the desert is alive. Not all dunes are grand. Some are subtle, small, rounded mounds, known as dome dunes. On Earth, they rarely grow taller than a few meters and often appear near larger dunes. They are smooth, without a slip face, more like sandy bumps than sculpted waves. On Mars, dome dunes are larger and more widespread. In some regions, fields of dark domes cover the crater floors, stretching for kilometers. They are tens of meters across, far bigger than their earthly equivalents. Sometimes they appear at the ends of dune trains, as if marking the boundary where shifting winds or reduced sand supply change the desert's character. Other times they stand alone, eerie and regular, dotting the surface like a patterned skin. It's a reminder that not every Martian dune is a spectacle. Some are quiet shapes, subtle, but telling of the forces at work. On Earth, parabolic dunes are common along coasts where vegetation anchors their arms, while wind scoops sand from the centre, leaving a U-shaped form. They are essentially inverted barchans, with the slip face on the opposite side. Mars, of course, has no vegetation, so how can parabolic forms appear there? The answer lies in obstacles: large mesas, rocks or mounds that anchor sand just as plants do on Earth. Around these features, wind channels and sculpts dunes into parabolic shapes, their arms stretching around the obstacle. In one striking HiRISE image, a dune arcs around a central mound, its slip face cascading down the far side. You can almost imagine the invisible winds diverted and reshaped by the hill carving patterns in the sand. This is Mars echoing Earth, but with its own alien twist. If dunes are the desert's architecture, then star dunes are its cathedrals. These towering structures form where winds come from multiple directions, piling sand into mounds with 3 or more arms radiating outward. They grow tall, sometimes hundreds of meters high, and remain largely in place, building mass year by year. On Earth, star dunes dominate parts of the Sahara, their scale only apparent when you realize the tiny dots on their slopes are people. On Mars, they are even grander. Inside Russell Crater, star dunes sprawl across the basin, their arms stretching kilometers across. From orbit, they look like dark stars, imprinted on the rusty canvas of Mars. What makes them especially Martian is their interaction with carbon dioxide ice. In polar regions, star dunes become draped with seasonal frost. In spring, as sunlight warms them, the ice sublimates directly into gas, eroding the dune surface and leaving streaks and fans of darker sand. It is as if the dunes themselves breathe, with the seasons exhaling plumes as the frost disappears. And at certain times of day, when the sun is low, shadows stretch across the crater floor, turning these dunes into sculptures of light and darkness. Mars reveals itself here not as barren, but as dynamic and alive. Dunes are not the only wind-shaped features. On Earth's beaches, you can see ripples, tiny ridges, formed by waves washing across sand. Mars has ripples too, but they are far larger. Instead of centimetres apart, Martian ripples can be a metre or more, with broad crests that stretch across fields of sand. From orbit, these ripples are hard to see, but rovers on the ground like Curiosity have captured them so up close. In one famous image, the rover's wheels rest on ripples taller than a person's knee, a scale that astonished scientists. These ripples are a reminder that even small-scale patterns tell big stories. Mars is shaped not just by massive volcanoes or giant canyons, but by the patient push of wind on grains of sand. Looking across these forms, barchans, Seifs, domes, parabolics, and stars, we see both parallels and differences. The same physical principles govern them: wind, sand, and time. Yet on Mars, the scale shifts, the details twist, and the results become uniquely Martian. On Earth, vegetation shapes dunes. On Mars, it is mesas and rocks. On Earth, moisture can bind grains. On Mars, frost of carbon dioxide rewrites the surface each season. Even the ripples, so familiar on a beach walk, grow outsized in the thin Martian air. By comparing the two worlds, we learn not only about Mars, but about the universality of nature's patterns. Physics is consistent, but outcomes are never identical. Each planet writes its own version of the story. When we think of Mars, we often imagine a still dead planet. But dunes tell another story. They move, they change, they breathe with the seasons. They are evidence of a restless atmosphere of ongoing processes that reshape the red planet every year. So next time you see an image of Martian dunes, look closely. Those graceful arcs and ridges are not static. They are dynamic landscapes, whispering tales of winds that sweep across a cold desert under a thin orange sky. And they remind us of something greater, even in a world so different from Earth. Patterns repeat. Nature rhymes across planets, but with verses all its own. The dunes of Mars are more than patterns in the sand. They are living landscapes, shaped by thin winds, shifting seasons, and forces that echo across worlds. They remind us that even on a frozen planet, millions of kilometres away, nature still follows its timeless rhythm, grain by grain, ripple by ripple. If you enjoyed this journey with us, don't forget to subscribe to Cosmic Compass for more stories of the cosmos. Until next time, keep exploring and keep your eyes on the stars.